Section 7.6 talks about constructors when you are creating a class, and a constructor is a member function that's used to initialize the data members of a class. It is automatically called when an object is created. It must be public, it must be named the same as the class, and it must have no return type. And so for the square, if I were to doing the square example, a constructor looks like this. When it's in line inside the class, you're going to have the keywords, or the name of the class has to match. So the class is called square, the constructor is called square. And in this case, we pass in a value. So this is called a parameterized constructor because it has a parameter and then it sets the side variable. When you declare your class outside, when you declare the method outside, you will have to use the scope resolution operator to say that the constructor square is associated with class square. And we will do this type of a prototype and this type of a definition later in the week, or later in our chapter here. For now, you're going to be using the inline constructor. When you overload a constructor, an overloaded method has methods that are the same name, different parameters. So when there's nothing in the parentheses, this is called the default constructor, and that's the one that gets called automatically. But if you put in a parameter or you have a parameter, it will automatically know that it's supposed to call this constructor. So based upon the parameters that are used, the computer decides which of these two constructors to use. And that's basically what this slide says. Constructors that have any number of, can have any number of parameters, including none. The default constructor is the one that takes no argument. If a class has any programmer-defined constructors, it must have a programmer-defined default constructor. So what that means is, if you have a parameterized constructor, you should have a programmer-defined default constructor as well. Example of a default constructor here for a square. So you have your instance fields here, and then you have your constructor, and the square has a default value of 1. This is an example of a parameterized constructor, but it also has a default value, meaning this. If I don't send it a value, it's going to assign 1 as a default value. Otherwise, it's going to take the value s that's assigned and assign it to side. So to create an object using the default constructor, you just declare it here like it's its data type square and square 1. To create an object with the constructor that has parameters, you list the parameters inside here. You can have more than one parameter. In C++, we also need to include a destructor in our classes. And the destructor is a public function that automatically is called when an object is destroyed. I will show you an example here with the circle class in just a moment. It has no return value, it takes no arguments, and there is only one destructor allowed per class. It cannot be overloaded. I'm going to switch to Video Studio and show you how to do that with the circle class. In our circle class example, after the two constructors, I have now added a destructor. And the destructor is really just your, it's a tilde, which is on your keyboard next to the number 1 key, followed by the name of the class, and then 2 parentheses, and then a semicolon for most compilers. Our compiler, here Visual C#, kind of didn't like that, so I included a beginning and ending brace here, and then it didn't give me a warning. But most of the time you don't need to include this beginning and ending brace here. But that's an example of a destructor. Now, you need this in C++ because C++ does not clean up its own garbage, so to speak. In Java, the garbage collection is done automatically. In C++, it is not. You can put inside these curly braces code, so you can actually see that the destructor is working. And so I made a couple lines of code that we're going to use here just to show you. And so first thing I'm going to do though is I'm going to run the program real quick. And this was just our demo program that calculated the radius. I think we had 3 circles. I did circle 1, circle 2, circle 3, and we outputted their results here. And so this is just what we had in class as an example, and that's off the screen there so you can't see it there. So that's what the output looks like. But if I go into the D constructor and I comment out those lines of code, and I also put in a system pause so we could see what was going on, you can see that once we run this code and it executes, you're going to see the same output that we had just a minute ago. And then if I press the enter key, the object was destroyed. So I have 3 circles here, so that deconstructor, or destructor, excuse me, not a deconstructor, but a destructor is going to run 3 times. And then the program is done. So in C++, you do need to add the destructor. Normally we don't put any code inside of it, so I'm going to comment that out. And that's going to be it for this particular video. We will pick up in the next video, I believe, with section 7.7, maybe? Doesn't matter. That's it for this video.